Okay, so here's page 4. Remember on page 3 we learned about tangent lines and normal lines. If you remember, tangent lines, they're the easier ones. All we need to do is put the function in the calculator, and then we do second draw tangent and give the location, right? X equals whatever, right? The normal line, although they're a similar concept, the calculator doesn't do that much for you, so you have a few steps, okay? First thing you're going to do is on your paper, you're going to write down the normal line equation, or not the normal, the point slope form, the point tangent form, gradient form. Looks like that. You're going to copy it out of the formula booklet, all right? So you're going to put that in your on your paper, and then you're going to do two things. One is in y1, you are going to put your function, your curve, okay? And then you're going to do second calc dy dx, and you're going to find the gradient, okay? Then you're going to take that gradient and you're going to make it into a perpendicular slope, okay? And that is going to be what you put into your slope. The other thing you're going to do is you're going to look in your table. When you look in your table, you are going to find the x and the y value if they didn't give you the complete information. If they only give you the x value, you can find the y value by finding the x value in the table and finding the y value there. Okay? So once you find that x and y value, you're going to put those into the x1 and the y1 values, okay? And then you're done. You have the trifecta. You've put in the 3 pieces of information you need, which is m, x1, and y1. I think the most tricky one is the m, because you have 2 steps. You have to do second calc dy dx, and then you need to put -1 over that slope, right? So let's do a few of these, because I know it's not the easiest thing in the world. In fact, I would say this is one of the hardest things in the chapter. Okay? All right, so number 5. Number 5 says, find the equation of the tangent and the normal to the curve with the equation x to the 4th minus 6x plus 2 at the point where x equals 2. So remember, there's 3 things they're going to give you. They're going to tell you whether you want the tangent or the normal, and they want both, okay? They're going to give you the curve, the function. What are you going to do with that? You're going to immediately put it in the calculator. And then they're going to tell you the location, which you're going to need later. Okay? So let's do this. Turn on the calculator. And first thing I'm going to do in the calculator is I'm going to type the function in the calculator. We're going to do the tangent. They asked for the tangent. So let's do the tangent first, because the tangent is much easier. So we put x to the 4th minus 6x plus 3. So we put it in the calculator, plus 3. Then we graph. Okay, maybe it doesn't even shows up. Okay, and now what we're going to do is we're going to find the tangent line. How do we do that? We do second draw tangent, which is number 5, and then we type in the location, which they told us is x equals 2. And there it is, and it shows us at the bottom. We need to round it a little bit, but it gives us the tangent line equation, which is y equals 26.0008, that's just 26x, right? Minus 45. We just, whenever it says 0, 0, 0, we just ignore that, right? Okay, so there's our tangent line equation. Y equals 26x minus 45. That's our tangent. Now we're going to do the normal line equation. Remember the procedure for the normal line equation. First thing we're going to do is we're going to write this formula on our paper. Where do we find it? It's from the formula booklet. Okay? It's the same formula we used in Voronoi diagrams. All right. We are going to fill in a couple things here. We're going to fill in y1, we're going to fill in m, and we're going to fill in x1. Where does the m come from? It comes from the derivative at the location x equals 2. How do we find the derivative at location x equals 2? We use second calc dy dx, number 6. And we just type in the location, 2. Enter. And the answer is dy dx equals 26.0008. We'll just put 26. Okay? So the tangent line slope is 26. Hey, look, what do you know? There it is, 26. Okay? Since they asked us for both the tangent line and the normal line, we're kind of repeating part of it, right? So the slope of the tangent line is m equals 26. We want the perpendicular of that, which means negative 1 over m, right? So it'd be negative 1 over 26. There we go. There it is. So that's what we're going to put in for m, okay? Last of all, we want to know the x, y coordinate at that point, okay? So basically, in this case, we have a function. We have a point that we want the tangent line, the normal line at. Remember, the normal line sticks perpendicular out from the curve, okay? So we want the equation of this line. What is this point? The point is x1, y1, okay? And in this case, we know that x1 is 2, but we don't know what y1 is. Well, remember, this point, 2, is a point on the curve. How do we find points on the curve? Second table, right? If we go to second table, there is the y1, 7, okay? So x1 is going to be 2, which they told us, and then the 7 we get from the table. It corresponds to 2. Now I can rewrite the whole thing. I can write y minus 7 equals negative 1 over 26 x minus 2. There we go. There's my normal line equation. Okay, so tangent line equation here, normal line equation here. All right, let's go to the next one. The edge of a lake can be modeled by part of the function x squared. Okay, so basically they're saying we're going to have a picture of a lake, and then we're going to put a fountain in the lake at the point where the equations of the normals at x equals 2 and x equals negative 2 meet. Now I'm gonna put this in the calculator, but basically what they're saying is the normal lines for these 2 points intersect in the middle, and that is where I'm going to put my fountain. All right, so let's draw that, or let's graph that in the calculator. We're going to put x squared in the calculator, because when they give us a function, what do? We immediately put it in the calculator. Then we can graph it. Okay, and we're going to draw 2 normal lines. Okay, we're going to draw 2 normal lines. One of the normal lines is going to be at x equals 2, and the other one's going to be at x equals negative 2. All right, so I'm going to do two separate procedures. So in both cases, I need to write my equation, right? The difference between the two procedures, in one, my location is x equals 2, and in the other, my location is x equals negative 2. Okay, so let's do the one where x equals 2 first. Remember, we're finding the normal line, so we need to do it manually. Okay, first thing we're going to do, we're going to put the function in the calculator. I already did that. I want to know what the m is at x equals 2. I want to know what the derivative is at x equals 2. So I do second calc dy dx, and then I type in 2. And that gives me 4. So my m value is 4. But since it's a normal line, I want the negative 1 over m value, which would be negative 1/4. And that's what I'm going to put into m. Okay? All right. And then what do I put in for x1 and y1? Well, for x1, they gave me 2, so I'm going to put that in there. Where do I get my y1? I get that by doing second table. It's going to be 4. I just look at where x equals 2, and I grab my y value there, 4. So now I'm done. Y minus 4 equals negative 1/4 times x minus 2. So that is my normal line equation at x equals 2. Let's find the normal line equation at x equals -2. Okay, it's going to be very similar. We already have the function here. Now what we're going to do is we're going to find the derivative at x equals -2. So we do second calc dy dx 6, and then we type in -2. And then our slope is -4. But we don't want -4. We want to find the perpendicular to that, which would be -1 over m, which would be -1 over -4, which would be the same thing as 1/4. And that's what we're going to put in for m. What are we going to put for x? The value they gave us, -2. Okay. What are we going to put in for y? We need to look at the table because they didn't give it to us. If you remember the problem on the previous page, they gave us both x and y. X was 1, y is 4. We didn't need to look at the table. But a lot of times, most of the time, they're not going to give you the y value, and you're going to need to find the y value by looking it up in the table. So the x value they gave us, the location is -2, and then we find that the y value is 4. So it's going to be 4. So now I'm going to write it again with everything filled in. Y minus 4 equals 1/4 times x minus -2. You could simplify that to x plus 2, or you could just put x minus -2. Make sure you use the negative sign. Okay? So this is the normal line at x equals -2. Finally, they say, find the equations of the normals, which we did, and the point where the fountain will be placed. Okay, where is the fountain going to be placed? It's at the intersection of the normals. Okay. Now, if this was on the IB exam, they would break it up into steps. First, they would tell you to find this normal line, then to find this normal line, and then they would ask you to find the intersection between the two. Now, why is it that this is a little bit difficult for the calculator? Do you remember this from Voronoi diagrams? Because the y is not by itself, okay? But we could put this in the calculator to do an intersection by adding 4 to both sides, right? And this one we could add 4 to both sides too. I'm going to put x plus 2 because minus -2 is plus 2. Okay, so now I have two pink formulas that I can put into y equals, into y1 and y2, and then I could find the intersection. So I'm going to do negative vertical fraction, -1/4. Makes it a little easier, less parentheses. If I put -1/4 with a vertical fraction, then I'm going to do x minus 2, close parentheses, plus 4. Okay, so that was my first one. My next one is going to look pretty similar, except for I don't have a -1/4. I just have a +1/4. So I do math, vertical fraction, 1/4, right arrow, x minus, or x plus 2, plus 4. So now I have two normal lines, and they are going to intersect at a certain place. Okay, so there's the intersection right there. Let's find the intersection. It'll be second calc, intersect 5. Enter, enter, enter. Since it's two lines intersecting, I don't need to be that careful about the intersection point. The intersection point is at y equals 9/2. X equals 0, y equals 9/2. So the intersection point is 0, 9/2. All right? If I want to, I could find a value for 9/2 by doing 9 divided by 2. It's 4.5. Okay? I'm going to draw you a picture just like this and this is just extra. Okay? We're done with the problem. The answer was 0, 4.5 or 0, 9.5. That's where the fountain will be placed. I'm just going to draw the function again, the curve, because then you can kind of see this picture here. Okay. So do you see there's the lake and this is the normal line at this point. This is the normal line at this point that I drew here. And they intersect right in the middle, which is 0, 4.5 or 0, 9/2. Okay? Last of all, for those of you who are going for a 5 or more in the IB exam, here are a couple algebra extension problems, okay? The gradient of the tangent of the curve with the equation ax squared plus 3x minus 1 at the point 2 comma b is 7. Find the values of a and b. Okay, so in this particular case, we can't use the calculator to find the derivative because the function is not complete, right? They gave us a letter here instead of a number. So we need to take the derivative using power rule. Okay, so instead of using second calc dy dx, we need to find the derivative using power rule. So how are we going to do that? We're going to, find the derivative. Ax squared, the derivative is going to be a, because a is just a number. We don't know what it is, but it's just a number, so we just let it lie. And then we bring down the 2, and then x to the first. We reduce 2 by 1. Power rule, right? 3x, the derivative is 3. The derivative of negative 1 is 0, so we just don't write it down. Okay, so here's my derivative. A times 2, x to the first, plus 1. We could simplify, plus 3. We could simplify a little bit by writing 2ax plus 3. Right? There's my derivative. The gradient of the tangent of the curve with equation f of x at the point 2 comma b is 7. So they're saying when x equals 2, the gradient is 7. So when x is 2, the gradient is 7. So if that's true, then I can write 2a2, because x is 2, plus 3 equals 7, right? Now I have an algebra equation I can solve. 4a plus 3 equals 7. 4a equals 4. I subtract 3 from both sides. Then I can divide both sides by 4. A equals 1. So a is equal to 1. Once I know that a equals 1, then it's pretty easy to find the y value. They want to know the b value, which turns out to be the y value of the function when x equals 2. Since I know a equals 1, now it just becomes a calculator problem, right? I can rewrite the function now with the a filled in. So it'd be 1x squared plus 3x minus 1. So let's write that down. Let's put that in the calculator. So I'm going to put, instead of ax squared plus 3x minus 1, which I can't put in the calculator, I'm going to put 1x squared plus 3x minus 1. So which would be the same thing as x squared plus 3x minus 1. So now I can just look in the table, and I can see that at x equals 2, my y value is 9, which means that b is 9. Okay, I admit that's a hard problem for us, but they would put it on the exam or something similar to see who gets a 7, right? To see who gets a 5, to see who gets a 6. Okay, the gradient, let's do number 9, another algebra extension. The gradient of the tangent to the function with equation blah, blah, blah. That here, do you see what they're doing? Same thing. They're putting a k in there, so we can't put it in the calculator and just do second calc dy dx. We need to use power rule, okay? Basically, the rest is kind of the same. When x equals 1, what's the y value? The derivative value is 3. Okay, so the first step is just like we did before. We're going to take the derivative using power rule. Then we plug in the 1 and the 3. The 1 in for x, and then we put the 3 in for the derivative value, and then we solve for k, okay? And then we're going to, when we know k, we can just put it in the calculator, and then we'll find the y value, okay? So first thing we're going to do is we're going to do power rule. Second thing we're going to do is we're going to substitute x and the derivative value. And then we're going to find k. And then, and last of all, we're going to just use the calculator to find y. Okay? So first power rule. We're going to do the power rule of that. So x squared plus kx plus 3, the derivative is 2x plus k, right? K being a number, the derivative of kx, derivative of 3x is 3, derivative of kx is k, okay? Then we're going to substitute in the x and the f dash that they give us. The x is the 1, the f dash is a 3, so I can put 1 here and I can set this equal to 3, and that would give me an algebra equation where I can solve for k. So it's 2 plus k equals 3, so k is equal to 1. Okay, so k is equal to 1. Now I have an equation that I can put in the calculator. X squared plus x plus 3. Using this, I could find the y value, right? Just like I did before. X squared plus 1x plus 3. Okay, and then I'm just going to look at the table. And then let's see, I want to know, oh, x equals 1, y equals 5. So b equals 5. B equals 5. Again, not an easy problem. I think that's it.